An unexpected discovery made by the James Webb Telescope has revealed city lights in space located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humanity at large have waited and researched to get a glimpse of life beyond our solar system. Any evidence perceived to back up this space fantasy has been welcomed with open arms over time. Recently, the scientific community received the shock of their lives when solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While scouting outer space and reporting vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. These lights were just as their name implied, lights looking like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in wonder. Every one of them is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to develop the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as tricky. He said so because the star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation, but not so for this exoplanet, as its infrared nature is quite different from that of its host star, named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, which came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The distinct heat signature of Proxima b will play a great role in discovering the universal secrets of its atmosphere, and this will be done thanks to the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on using the telescope to reveal the mysteries surrounding this planet's atmospheric components. They also aim to use the Webb telescope to assess the possibilities of residing on this exoplanet. The James Webb Telescope has an infrared sensitivity that's poised to explore what happens at Proxima Centauri b's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify whether the rumors of city lights on Proxima b's night side are true or not. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than the starlight. Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. A spectral edge also reflects incoming light rays at the same time. When Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods similar to those we have on Earth, with the daytime heating up due to solar heat and the evening cooling down. The planet is known to have temperature fluctuations determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far apart. Without the moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot, like a black body, and the night side will drop into cold darkness. The degree of temperature variation is a good subject for astronomers to explore in order to understand Proxima b's atmospheric composition more deeply. Having unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around Earth aligns with Proxima b's orbital period, making complete observations of its day and night periods possible within 11.2 Earth days. If it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good indicators of life include the presence of gases like oxygen, water vapor, and methane. If these elements are found on the planet, it could mean that it supports habitable conditions. The process of successfully determining this requires scientists to meticulously capture and examine light rays that move through the planet's atmosphere. This is a very challenging task to undertake, even though the JWST possesses great capabilities for characterizing planetary atmospheres. It has a different major objective. The telescope has been customized to analyze only variations in water vapor, carbon dioxide, and methane concentrations. When it comes to identifying bonded oxygen, a vital indicator of life, the JWST is limited in this area. Even so, the telescope still has valid reasons to search for other elements on the planet, such as ozone, which provides an accurate indication of atmospheric vitality. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth. To carry out a thorough atmospheric investigation, astronomers are now leaning toward ground-based observatories like the Extremely Large Telescope (ELT), fondly referred to as ELT. The ELT is a telescope scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It'll produce data on these planets that will offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone are eagerly waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope remains a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the Webb telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes, which is to reduce the amount of bright light coming from a planet's host star so that astronomers can better see the light reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites shaped like umbrellas, similar to using your hand to block out rays of the sun to enable you to see an object more clearly. By reducing the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from distant exoplanets, allowing for vivid analysis of their atmosphere and the likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those produced by geological processes, such as volcanic activity. Astronomers aren't giving up on understanding the characteristics of exoplanets, so they are better able to spot signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we're better positioned to understand the intricate workings of the universe and our various roles in it. After searching through all the planets in space, scientists have yet to find any that host life, despite decades of searching for signs of life. The quest for forms of life on other planets continues. Are we alone in the universe? For millions of years throughout human civilizations, humans have always wondered whether they are the only ones in the universe. This is an age-old longing that still hasn't left us in the present time. Even now, scientists have the James Webb Telescope in outer space, trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life at the same time. A popular narrative has spread in recent times that some aliens are truly out there in the stars, just waiting for humans to find them. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called Search for Extraterrestrial Intelligence (SETI) in 1984. Known as the SETI Institute, it is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. The reason for focusing on radio signals is their ability to travel long distances without getting scattered or absorbed, unlike other types of radiation. Due to this characteristic, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Allen Telescope Array, located in the Cascade Mountains of California. Though the SETI Institute has religiously observed for signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter remains enthusiastic, hoping for a positive result as they aim to use the tools of the 21st century to accelerate the search. In her words, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of that continued until recent reports from NASA implied that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is the giant trump card played by humans in getting a finite grasp of the universe. It's currently the most advanced instrument in all of mankind's history, designed to unearth the mysteries of the universe. The telescope is currently floating about 1 million miles away from Earth, sending accurate details about the earliest periods of the universe. It's designed to capture previously elusive facts about space as it delivers greater clarity on the formation of galaxies, planets, and stars alike. Astronomers haven't failed to capitalize on the JWST's cutting-edge technologies, such as its stellar camera features and filters, to spot and analyze the delicate colors that surround celestial objects. Researchers are comfortable using the telescope to collect data about the physical properties and chemical compositions of celestial bodies located far away in the cosmos. This was achieved by isolating specific wavelengths of light. Far beyond just observing, the Webb telescope continuously gazes upon the atmospheres of exoplanets for faint traces of life, no matter how little. It has an unrivaled power to analyze the interplay of time and space, exposing some of the most intriguing findings ever. One such finding is the discovery of more mass than was previously believed to have existed in the universe. This mass has been stashed away in several giant galaxies, effectively casting doubt on the earliest layout and proportions of the universe. Humanity has since set out to explore the farthest reaches of the cosmic plane, using the JWST as an integral tool for achieving this. Through the telescope, new information on isolated worlds will be documented, and more astrophysical data will become available to solve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system wasn't explored. Since that time, however, astronomers have identified over 4,000 exoplanets that orbit distant stars, showing just how far human ingenuity can go. Still, all of these discoveries are regarded by NASA as just touching the tip of the celestial iceberg. Scientists believe there are trillions of exoplanets scattered across the cosmos that haven't been discovered yet. Not giving up over the decades, scientists are still exploring space in hopes of discovering alien habitats in places where humans haven't ventured. They've had glimmers of hope during this quest. For example, when the Galileo spacecraft traveled to Jupiter, its spectroscopic instrument unknowingly revealed a unique spectral signature that lent credence to the possibility of extraterrestrial vegetation. As the search for life beyond Earth continues, the James Webb Space Telescope stands at the forefront, promising to deepen our understanding of the cosmos and potentially unveil the existence of life beyond our planet. With every observation, scientists edge closer to answering one of humanity's oldest questions: are we alone in the universe? The quest persists, fueled by curiosity, innovation, and the boundless possibilities that lie in the vastness of space.